This video is about IB past paper about trig equations. Number 3, let f of x equals 4 cosine x over 2 plus 1. X is greater than equal to 0, less than equal to 6 pi. Find the value of x for which f of x greater than 2 square root of 2 plus 1. For f of x greater than 2 square root of 2 plus 1, we know f of x equals this, so we plug in. You will get 4 cosine x over 2 plus 1 greater than 2 square root of 2 plus 1. Since this is a linear inequalities, we need to isolate the cosine x over 2 on the left side of this inequality. So minus 1 both sides, you will get 4 cosine x over 2 greater than. Combine like terms, you have 2 square root of 2. Then we divide it by 4 both sides. Since we know multiply or divide by negative number, we switch the symbol. This is a positive 4. That's the reason your symbol stay. Reduce. We have cosine x over 2 greater than reduce square root of 2 over 2. This is the first step. Second step, we need to solve cosine x over 2 equals the square root of 2 over 2. Since the square root of 2 over 2 is a positive, for cosine, we will go to the first and fourth quadrant. We know the reference angle is 45 degrees equals pi over 4. We know the domain is between 0 and 6 pi. Therefore, for x over 2 will be between 0 and 3 pi. We need to draw the diagram between 0 and 3 pi. We have 0 pi, 2 pi, 3 pi. Get started from 0 ending at 3 pi. We only need to write down the pattern for the first and fourth quadrant. For the first quadrant, it will be pi over n, 2n plus 1 pi over n. For fourth quadrant, we only have 2n minus 1 pi over n. Now, we know the n equals 4. Then we plug n equals 4 into this 3 pattern. And we know here is x over 2. Therefore, we have x over 2 equals pi over 4, 9 pi over 4, 7 pi over 4. Then we multiply by 2 both sides. You will get the x equals pi over 2, 9 pi over 2, and 7 pi over 2. These 3 will be the solution to this equation. We already got the solution to this equation. That is x equals pi over 2, 9 pi over 2, and 7 pi over 2. The third step, we need to draw the graph for y equals cosine x over 2 and y equals square root of 2 over 2 to find the intersections. So for y1 equals cosine x over 2, we know the period equals 2 pi over b. b is the coefficient of x, that is 2 pi over 1 over 2, that equals 4 pi. Now let's sketch the graph. Since the period is 4 pi, I will say this is 4 pi. Then half, half, half. This will be 2 pi, half of 2 pi will be pi. And amplitude will be 1, here's a negative 1. For positive cosine x over 2, the graph will be like this. We need 5 points. So we get started from the maximum, keep going like this. Since the domain of the inequality is x greater than equal to 0, less than equal to 6 pi, we need to move on. This is a 5 pi, here's a 6 pi. So keep doing the pattern like this. Then I will connect these points. That's the y1. For y2, we need to draw is a square root of 2 over 2. It's like a 0.7. Suppose this is a square root of 2 over 2. So we will draw this horizontal line. This will be the y2 equals the square root of 2 over 2. You get 3 intersections. It will be the solution we got from cosine x over 2 equals square root of 2 over 2. Let's label pi over 2, 7 pi over 2, 9 pi over 2. Greater than, that means above y2 equals square root of 2 over 2, which means this is the solution. Since we don't have an equal sign, that's the reason we will do over here is an open circle. Open circle. So we can write down the solution now. It will be x greater than equal to 0, less than pi over 2, or x greater than 7 pi over 2, less than 9 pi over 2. You can also write down the solution in interval form. That will be this. This will be open parentheses. Union with, this is an open interval, 7 pi over 2 to 9 pi over 2. This will be the solution to question 3. Let's go to number 4. Let A equals sine B. B is a reference angle, which means B greater than 0, less than pi over 2. Find in terms of B. The solution of sine 2x equals negative A. X greater than equal to negative pi, less than equal to pi. We want to solve sine 2x equals negative A. We know A equals sine B, so we substitute. We have sine 2x equals negative sine B. We know the given interval is between negative pi and pi. So for 2x will be between negative 2 pi and 2 pi. We need to draw the diagram between negative 2 pi and 2 pi. We need to draw positive domain, which is from 0 to 2 pi. So we have 0, this is a pi, this is a 2 pi. We start at 0, end at 2 pi. Then we need to draw negative 2 pi. Negative angle will be clockwise. So from this side, 0, negative pi, then negative 2 pi. We start at 0, ends at negative 2 pi. Since negative sine b will be in the third and fourth quadrant, so we only need to write down the pattern for third and fourth quadrant. From given information, we know B is a reference angle. So B is in the first quadrant. For the third quadrant, we have a pi plus B and a negative pi plus B. For the fourth quadrant, we have a negative B and a 2 pi minus B. Therefore, for this sine 2x, we can write down sine pi plus B or sine negative pi plus B or sine negative B or sine 2 pi minus B. In this way, we already got 4 trig equations. Let's label these 4 equations. From the first equation, we get 2x equals pi plus B. For second equation, we get 2x equals negative pi plus b. For third equation, we get 2x equals negative b. For the fourth equation, we get 2x equals 2 pi minus b. Then we divide by 2 to get the x equals pi plus b over 2. From this equation, we get the x equals negative pi plus b over 2. For third equation, we get the x equals negative b over 2. From this equation, we get the x equals 2 pi minus b over 2. We have 4 solutions. Pi plus b over 2, negative pi plus b over 2, negative b over 2, and 2 pi minus b over 2.